All right, let's talk about a word that probably sends shivers down the spine of anyone who's ever taken a high school chemistry class, the mole. Yeah, I know. But what if I told you it's not some terrifyingly complex idea? What if it's actually just a really clever trick for weighing stuff you can't even see? Stick with me, because we're going to break it down.
Okay, so let's put ourselves in a chemist's shoes for a second. Your whole job really is mixing things together. But you're not just throwing stuff in a beaker. You need exact numbers of atoms and molecules. And here's the problem, right? The very things you need to count are totally invisible. And their numbers, we're talking mind-bogglingly huge. I mean, more atoms in a single grain of sand than all the grains of sand on every beach on Earth. Seriously, how on earth do you count that?
So yeah, that was the big puzzle. How do you build a bridge between two totally different worlds? You've got the invisible world of atoms on one side, and on the other, our world. You know, with beakers, scales, stuff you can actually touch and measure. They needed a way to connect the two.
And I really want to drive this point home. The numbers are just insane. We're talking trillions upon trillions of atoms in the tiniest speck of matter. Counting them one by one, forget it. It's not just hard, it is literally, physically impossible. You'd be counting for longer than the age of the universe. So, clearly, they needed a shortcut. A really good one.
And the solution they came up with is, when you think about it, kind of beautiful in its simplicity. If you can't count things one by one, well, don't. Count them in groups instead. It's a strategy we actually use all the time in our daily lives, maybe without even realizing it.
So what did they do? They didn't invent some crazy new form of math. Nope, they just took an idea that's super familiar to all of us. Think of it like this. They came up with a chemist's version of a dozen. But, you know, a dozen that's built for the world of atoms.
I mean, we all know what a dozen is. It's 12. You go to the store, you ask for a dozen eggs, not 12 individual ovoids laid by a chicken, right? It's just a word, a convenient name for a group of 12 things. It's a shortcut.
Okay, you ready for this? A mole is exactly the same idea. It is just a name for a group of things. The only difference is that the group is, well, it's this. It's a mind-meltingly massive number. That right there, that's the chemist's dozen.
Now, writing that whole thing out is a pain, so we use scientific notation. 6.022 times 10 to the 23rd. And this number is so important, it has its own special name, Avogadro's number. But this is where you should be asking, wait, what? Why that specific number? Why not just a 1 with a bunch of zeros? Why something so weird and precise? Well, that's where the real genius of this whole idea comes in. Because this isn't just a big number. It's like a magic conversion key. It wasn't pulled out of thin air. It's the one specific number that unlocks the connection between the tiny world of atoms and our big everyday world.
So let's go back to that bridge idea. On one side, you have the atomic world, and down there, scientists measure the mass of a single atom using a special unit called an atomic mass unit, or AMU. It's an unbelievably tiny unit, and the whole system is based on carbon-12. By definition, one atom of carbon-12 has a mass of exactly 12 AMU.
But now, let's cross the bridge to our side. Here in the lab, we don't have a scale that can measure AMU. It's just too small. Our scales measure in grams. Trying to weigh out 12 AMU would be like trying to weigh a single speck of dust on a truck scale. It's impossible. So you see the problem? How do we connect the theoretical mass in AMU to a practical weight in grams?
And this is the secret sauce. Avogadro's number is the key. It turns out that if you gather exactly 6.022 times 10 to the 23rd atoms of something, their total mass in grams is the exact same number as a single atom's mass in AMU. It's a perfect conversion. That's not an accident, it's the whole point. And this is what makes the moles so incredibly powerful in the lab. It turns an impossible counting problem into a dead simple weighing problem. It's like a recipe. You want 1 mole of carbon atoms? Easy. Step 1, look at the periodic table. Carbon's atomic mass is about 12 AMU. Step 2, go to your scale and weigh out exactly 12 times grams of carbon. Step 3, that's it. Congratulations, you are now holding 1 mole of carbon. Boom! Done. So who's the genius we have to thank for this amazing idea? Well, like a lot of big ideas in science, the story is a little more complicated. It wasn't just one person yelling Eureka in a lab. And here's a fun fact that trips a lot of people up. The number is named for Amedeo Avogadro, right? But get this, he never actually knew the number. He had no idea what it was. His contribution was the core idea, the theory, that equal amounts of gas have the same number of particles. That was the seed.
but it took almost a century for other scientists to do the hard work of actually measuring and calculating the number itself.
Yeah, this whole thing was a slow process. The actual word mole first popped up in the 1890s from the German word for molecule, but it wasn't until 1971, think about that, 1971, that it became one of the official base units of science. And it got another major update just a few years ago in 2019 when they redefined it based on a perfect, unchanging constant of nature.
Okay, so at the end of the day, why should we care? It's a big number. It's a clever trick, great. But why does it matter so much? Why is it a bedrock of basically all modern chemistry? Because the mole is the recipe book. It's what lets chemists take a chemical reaction written on paper and actually do it in the real world. You see an equation for making water? That's not just 2 tiny hydrogen atoms and 1 oxygen atom. It's a recipe that says, take 2 moles of hydrogen and 1 mole of oxygen. That's how you get predictable results. It's the reason we can precisely create everything from the medicines that keep us healthy to the silicon in the computer chip you're using right now.
So really, the mole is more than just a number. It's a monument to our own cleverness, right? It's a beautiful idea we invented to connect the invisible world of atoms with our everyday reality. It makes the unseeable seeable and the uncountable, well, countable. And it makes you wonder, doesn't it? What other secret numbers, what other hidden bridges are out there just underneath the surface, quietly shaping the world we live in? Thanks for joining me for this explainer.